Booking an airplane ticket with the expectation of spending a few hours in the air when you need to travel a long way, such as across continents, is common. All the points of interest are, however, so far away when it comes to space travel that you must go more quickly. To more swiftly reach outer space, space explorers have always sought to travel faster than the speed of light. In essence, each strategy has a lot of problems, but researchers have identified a new approach. What is the mechanism? Which conditions apply? When can you start using it for travel? Come along with us as we introduce a new method of traveling faster than light. It would be challenging to see this video without light, which is both fascinating and crucial. We're able to walk without unexpectedly bumping into objects because of the sun and other artificial light sources that humans have created. However, you've probably heard that light travels quickly. But how fast is light? It's interesting to note that the foundation for most other measurements is the exact speed of light, which is known. In a vacuum, light moves at a precise speed of 299,792,458 meters per second, or 983,571,056 feet per second. Accordingly, light will travel 186,282 miles in a single second. When you turn on a light in a dark room, the light fills the space almost instantly, and you won't even notice that it's moving. This is because light moves so quickly. The light year, which represents the distance light can travel in a year, is another unit of measurement related to light. This amount equates to roughly 6 trillion miles, or 10 trillion kilometers. It's one method by which astronomers and physicists gauge the vast distances present across the cosmos. As was previously said, the universe is so big that it can take years for light to travel between 2 points. For example, the moon is roughly 1 light second away if light travels from the moon to our eyes in 1 second. The sun's around 8 light minutes distant, but sunlight travels further and takes longer to reach our eyes, taking about 8 minutes. It takes light from Alpha Centauri, the star system closest to our own, around 4.3 years to reach us, making it 4.3 light years away. From a few light years to a few billion light years out, there are other stars and objects besides our solar system. Because of this, everything that astronomers see in the far reaches of the universe is actually the past. When they examine distant objects, they observe light that depicts those objects as they were at the moment the light left them. Even though light can be used for a variety of exciting purposes, researchers have looked for ways to move at the speed of light. This is intriguing, since it means that humanity will eventually exist on other planets. For instance, billionaire CEO of SpaceX, Elon Musk, wants to establish a colony on Mars. But his explorers must endure a minimum of 5 months of space travel before arriving there. Depending on how close the 2 planets are to one another, this may potentially be almost a year. And that's before it lands on the red planet with all the dangers it carries. They can, however, travel at the speed of light and complete the lengthy journey in under 4 minutes. To achieve moving at a very fast speed, researchers have experimented with a wide variety of techniques. However, there's always been a problem that other solutions cannot address, until a scientist revealed the brand new finding we will share with you in this video. It's extremely difficult to even approach 1% of the speed of light, which is still quite quick considering you could go from Los Angeles to New York in just over a second. One word sums up the issue: energy. Kinetic energy is the term used by physicists to describe the energy that any moving thing possesses. You must boost kinetic energy to move more quickly. The issue is that kinetic energy is needed in large quantities to accelerate. It takes 4 times as much energy to make anything move twice as fast. 9 times the energy is needed to make something move 3 times as quickly, and so on. For instance, it would take 200 trillion joules to accelerate a kid weighing 110 pounds to 1% the speed of light. That's nearly equivalent to the daily energy use of 2 million Americans. Consider the M drive, which was promoted as the device that would swiftly transport mankind to the universe's furthest reaches. Theoretically, this invention, which is already patented, works by enclosing microwaves in a shaped chamber, where their bouncing generates push. Since there's no fuel input and no thrust output, the chamber appears to be moving just from the outside because it's closed. Newton's second law, which says that force is equal to the rate at which momentum changes, is the foundation of the M drive. Therefore, an electromagnetic, EM wave moving at the speed of light has a certain momentum that will be transferred to a reflector and produce a minute force. The M drive, which seems straightforward yet fundamentally flips our understanding of physics on its head, is enabled by this accumulated little force in huge amount. We wonder how the waves begin to move, how they continue to move, and where their impetus comes from because neither energy is entering nor leaving the scene. Many scientists don't even take the M drive seriously, because you can't have spontaneously created momentum without an understandable push. The M drive would invalidate a lot of what physicists believe to be true about the cosmos if it were to succeed. The M drive was also put to the test by physicists at Dresden University of Technology, who discovered that the encouraging NASA and Chinese studies demonstrating thrust were all false positives explained by external influences. The warp drive, however, holds immense promise, as demonstrated by Eric Lentz, a physicist with more than 10 years of experience in real-world applications. Lentz was not the first to work on developing the warp drive from a sci-fi concept to a practical reality. The Mexican mathematician Miguel Alcubierre was the first to try it. His suggestion was the first in a body of work that was eventually published in 1994 on warp drives. Unfortunately, the Alcubierre warp drive, as it's come to be known, needs an astounding amount of energy as well as the dreaded exotic matter as a co-ingredient. Researchers haven't actually seen this highly radioactive material in nature, much less developed it. It's merely speculative. Since then, a few modifications have been proposed, including one by Dr. Harold G. Sonny White, a former NASA engineer in 2010, to the physical design of the Alcubierre drive. His revision decreased the energy requirement to a more manageable level. However, it was still impractical because the method still needed exotic matter, albeit much less than the Alcubierre system. A different team of Swiss researchers by the name of Applied Physics, or APL, presented their own theory. It's interesting that their drive's warp bubble may be created without using any unique materials. Though exceeding the speed of light is the ultimate goal of space travel, their model was unable to do it. Lentz begins by referencing the physical construction of the traditional Alcubierre drive, on which practically all other solutions are more or less based, to illustrate how his idea differs from those that have already been put out. According to him, the Alcubierre solution gave a clear illustration of what a warp drive would do, which is to constrict the space directly in front of the ship or transport center section and to expand the space directly behind. This image depicts the warp drive as a curved wave that a ship will ride to its destination. Lentz contends that while being the foundation of warp travel, it's not even the most important component. He claims that an answer put forth by scientist Jose Notario in 2002 demonstrated that the expansion and contraction were not required to move the ship ahead. He had considered how a warp could be made utilizing only regular matter and not exotic matter as a result of his efforts. Notario was able to demonstrate that the expansion might be insignificant or nil everywhere and still accomplish the same objective of moving a ship. This is an important development because it eliminates the need for the exotic matter that nearly all theoretical warp drive solutions use to warp the space in front of and behind the potential passenger. And by adding to Notario's theory, Lentz developed his own variant that, in his opinion, is more practical because it's based on traditional physics. Lentz stated that his method differs geometrically from Alcubierre, and most others because of how the energy is distributed around the warp bubble, aside from the significant material distinction. The energy is contained in a tiny torus between the area of strong contraction and expansion in the Alcubierre solution, where the energy density and curvatures are separated from one another to the maximum extent possible. Instead, Lentz's model has closely associated curvatures and sources, with nearly perfect overlaps between the high energy density and high expansion and contraction zones. Lentz's idea is perhaps more workable as a warp solution than those previously offered because of these geometrical differences between it and the conventional ideas. Lentz's warp drive is still a theory, of course. However, he does see some immediate actions that may be taken to try to bring his theory closer to reality, which, like all prior drive hypotheses, includes lowering the amount of energy required. From here, where does Lentz want to direct his warp drive? The next goal, according to him, is to use a modern fission reactor to create a warp bubble that's capable of traveling at 1% the speed of light. The physicist stated that he would think about patenting his warp drive, but he made it clear that his work is only a small portion of a larger, quickly expanding body of work in the area. The physicist also stated that the recent rise in new warp drive concepts since Alcubierre's 1994 proposal gives those in his field hope that a real, testable version may be closer than we think. Lentz remarked that it's been encouraging to observe the rapid advancements made recently in the warp drive field. He anticipates many more developments in the coming years and believes they're already underway. Please share your thoughts about the speed of light in the comment area below.